Alright, hey everyone. I'm using a new microphone today, so let me know if you can hear me and if any changes need to be made to the audio. I'll go ahead and start, and again, just let me know if there's anything wrong with the audio throughout the stream. So, I've done a lot of work off camera, off stream on this Locomotion, but there is actually less here, less functionality than there was with the last stream. I've rebuilt the animation blueprint from the ground up. The structure of it is much better, much more efficient. But the only thing I've implemented right now are forward distance matched starts, forward distance matched stops, and the looping state. All my time really has just been restructuring the animation graph. So I want to go ahead and show you guys what changed. And I also want to give a ton of credit to a friend of mine, Ryan, who's also a moderator in the Outcast Dev School Discord. He's been working on his own distance matching Locomotion system for a long time. And we're on a team together and working on a game, and he gave me permission to use some of his logic, some of his stuff in my video series and his stream. So, let's start with the event graph here. The event graph is very, very simple. Just an event blueprint initialize animation. I'm getting the pawn owner, and if that's valid, I'm casting to the character class and setting a character variable. Now, so the reason I'm doing it off of initialize animation is because I'm only casting to the character class once. When the animation blueprint is initialized. So the reason I'm casting to character and not to the Paragon character specifically is just to make the anim graph a bit more universal, a bit easier. I don't want to work with anything native to the Paragon character. That will make it easier to switch out and use a different character. This anim graph will work with any character. You just need to replace the animations. Now, I also have these anim notify events, but I'm going to come back and cover these later. So, our main state is this Locomotion state. This is where eventually we might have a swimming, flying, I don't know, but climbing maybe even. But right now we just have a ground locomotion. And inside of it, we're just using a cached pose ground locomotion, which we are getting from this ground locomotion state. And this is the state machine where everything that is currently implemented happens. So, we start in an idle state where we just play an idle animation. Simple enough. But the transition is a bit different. All the transitions now use booleans. A single boolean that's just an enter start or and the transitions are shared, so that every transition going into start is just this shared start transition, meaning that which is just a nice way to organize your anim graphs. For example, if I create a new state here and I plug idle into it, and let's say this is a start state, I can just use shared, click start, and use the logic for that transition. And so whenever a state transitions, or I need to transition to a state, that boolean will be set to true in the update graph, and I'll transition into that state. I'll cover that logic shortly here. The start state is really simple. We're just blending between a start animation A and a start animation B. I'm hoping to get orientation warping added back into the starts and stops in this stream. Our loop, we're just getting a lean angle, multiplying it by -1, and we're using blend spaces for jogging, slopes, and leans. Which just means that the character can lean as we are turning. And then we're doing orientation warping and blending our poses by int. Nothing has really changed much here except for how I'm calculating the cardinal direction. But we'll get to that. So we also have our stop state, same as our start state. We're just going to be blending between two of them. Right now I haven't implemented the logic for picking the animation yet. That can go back into the idle. So now let's go over to our update graph where a whole lot of the logic happens. So the first thing we do is we set locomotion values, such as actor location, actor rotation, is accelerating, velocity, speed, so on and so forth, as well as the variables we need to use the distance matching prediction functions. Now, I also want to say, I know I'm going through this a little bit fast here, because these streams are just for me to work on this locomotion system while you guys watch, so that we can talk, discuss Locomotion, Unreal Engine 5, anything really. And I just want to try to bring you guys up to speed so it's easier to understand, but soon I do want to start a video series where I go through all the individual components of the system, create them one by one, and really explain all the logic behind everything. And now finally, after all of that, I've taken this logic straight out of the original Paragon blueprint. For just calculating a lean angle, I get a previous actor rotation, an actor rotation, I get the delta, get the yaw from that, and again, this divide by 1 I don't think is really necessary. I don't know why it was there to begin with. It'd be easier to make this multiplication, but then again, I just copied and pasted it really. And I'm setting the lean angle, and I copied and pasted it a couple of minutes before I started the stream. So that's the first function, set locomotion values. It's just most of the values that we will need for the animation system to function. Next, we set our transition bools, where we're just setting when we should enter our states. And this approach, again, is something that Ryan came up with, and I've implemented it in my animation blueprint because I really like how clean it is, just having all the transitions as a single boolean and then just having pure functions for checking if the states, if it's time to transition into a state. And so for should enter idle, we're just saying if we're stopping and our speed is nearly equal to 0 and we are not idling right now, we return true. We're starting, we make sure we're not currently starting, and we make sure that we're accelerating. And if that's true, we output true. We're entering a loop if we are starting, and if our distance to target, the absolute value of that distance, is greater than a start threshold, which I have set to 80, and that just means when we start, we're distance matching from a starting location. And once our distance is greater than a certain threshold, we blend out into the loop. And we also don't want to enable we don't want to transition into a loop if we're already in a loop. So we make sure that we're not currently looping. So that these values are not set to true while we're inside of the states that they control the transitions into. And finally, we have should enter stop. So we're not stopping, we're not accelerating, which is essentially the same as has movement input. As soon as you don't have any movement input, the acceleration vector goes down to 0 in the character movement component, and we only transition into a stop if we're looping or if we are starting. So once each of these booleans is true, we enter into a state. But we have to then set these booleans to be false. And we do that by, let me close out of my functions or it'll be too hard to navigate through here. Well, each of these transitions each of these states has has two events set up with them, an entered and an exited. You can add them by just clicking on your state and creating an event name that'll create an event. And then I've put them in my event graph. So when we enter an idle, for example, we set this value is idling to true, and we set the enter idle to false. And when we leave it, we set is idling to false. We also reset our distance to target after we've stopped so that it works when we start. And then we essentially do the exact same thing for all of the other states. Now, the next thing in our update graph is that we update ground state values. First, we have a move delta, which we're always updating, and it's just the distance between the actor location and the previous actor location, which is the location from the previous frame, which we set at the end of our update graph. So now we have a branch here for each of our states. If we're idling, or if is idling is true. If is idling is true, or if enter idle is true, well, we don't do anything because there's nothing we need to update. But the logic is the same for each state. That is because for the first frame, the first tick of a state, when we're entering it, that is, for example, is starting. I'm not sure if it's true or not true. It might update fast enough and be true, but either way, if it takes a single frame for it to update, we still start updating these values because at that point is starting is true. And so we update values while we start. We update our distance to target, which is the move delta plus the distance to target. And that is because if we just get the distance between our current location and a target location, a start location, that's just not going to work. We could run in a tight circle around it and never get out of our start state. So we don't even need to use a starting location here because the starting location is the actor location. So all we have to do is add up the move delta frame by frame to know how far we've moved. It's really the difference between, what's the terminology here? Yeah, I can't think of it. Never mind that. But we want to use the delta, not just a distance. And then we determine our cardinal direction. I'll go into this function in a moment, but we plug in our current cardinal direction and our current direction. Whoops, did not mean to enter that already. And we have a step delta and a skip delta, which means that we don't always transition into a cardinal direction at the same threshold. If we're at 45 degrees, because our step delta is 60, that's the variation in degrees you have before it should actually be 65. There we go. Before we transition over into the next state. So if we're going forward with a direction of 0, straight forward, but then we start going at a 45-degree angle. Well, our step delta is 65. We have to be 65 degrees away from the direction 0, straight forward to transition into moving right. But we can also be going at that 45-degree direction from while our cardinal direction is right, and we don't transition to forward until we're 65 degrees away from right. Skip delta is the functions the same way, but that's for skipping one cardinal direction, going straight from forward to backward or left to right, or vice versa. So we set our cardinal direction with that. Then we calculate a locomotion angle, which we use for our orientation warping. And let's look at this one first, because cardinal direction is a little bit more complicated. So we have a local real variables here. We just take our direction input and we set a local locomotion angle north. But for everything other than north, we also add an offset. East is -90, south is 180, and west is 90. The reason we do this is that when you're orientation warping, you're rotating bones around so that you are rotating the legs and the body, and you need to input the degrees to rotate it by. But let's say you're going right, well, your direction variable is going to be 90, but you don't want to rotate yourself -90 or rotate yourself based on that variable or by that variable, because that 90-degree offset is already baked into the animation. So you need to account for that offset with the orientation warping. And so once we have this offset, we just get the current, we have a switch on int for the current cardinal direction. 0 is forward or north, 1 is west or right, 2 is south or backwards, and 3 is left or, well, east. And that just determines what we are returning from the function. And we use that to set our locomotion angle, which is what we use in our loop right now, right here, in the orientation warping node. Now we have, let's look at the cardinal direction function. So where are we? I opened up way too many tabs here. I'm going to close out of a lot of these. Okay. So determine cardinal direction. It's the biggest function here. Ryan had some great logic for it, so I'm just using his. So I have the current cardinal direction input. I'm switching it. And what we're doing is we're just using our relative direction and the step delta to determine if our relative direction is greater than the step delta. So let's say our current cardinal direction is forward. Our relative direction is, let's say, 90 now, which is right. The step delta is 65, so it is true our relative direction is greater than 90. So now we want to say, is it greater than the skip delta? Should we be transitioning to backwards, or should we be transitioning to right? So if it's greater than the skip delta, we say set the cardinal direction to backwards, but if that's false, well, we know it's greater than the step delta, so we set it to right. But if the relative direction is not greater than the step delta, we want to check if the relative direction is less than the negative step delta. So this would mean we're over in the other hemisphere and we might want to go left. The logic's the same, but if that's not true either, well, we haven't rotated far enough to change our current cardinal direction. Now, forward is the least complicated. It gets a bit more complicated if you're already going right or left, because we want to make sure our local direction offset that we are, because we're offsetting it, is not less than -180, and if it is, we want to add 360 to bring it back around to the positive. And that's really all the difference there is there. The logic is the same, it's just the output is different. And for backward, so the logic here is the same for left, but just the inverse. For adding that 360, I'll show you guys. You'd subtract 360 instead and check if it's greater than 180. and we'd add our offset of 90. But for backwards, it's the most complex. We have a relative direction of negative 180. I'm sorry, we're offsetting that by 180. We're subtracting 180. And we're saying, hey, if this is less than 180, then we want to add 360. But if that is false, we want to check if it's more than 180. And if that is true, we want to subtract 360 just to make sure we never get a value greater than 180 on the negative, so less than 180. So, I'm sorry, going a bit faster. Brain is going a bit too fast for my tongue. I apologize. So, we never want to have a local direction offset that is less than negative 180 or greater than 180. We want to keep it locked to that range for our logic here to work. So I'm gonna just go through this whole thing here just so that any of you guys can pause and look at this logic and copy it again. I'm going to be really breaking this stuff down much more slowly and talk about it a lot more in a video series, just like my Unreal Engine 4 distance matching series. Guys have any questions, ask them in the live stream chat. I'm happy to stop showing you what's changed, and I'm happy to answer questions you have. It doesn't have to be about this either. It could be just Unreal Engine questions, Locomotion questions, anything really. That's why I'm doing the live streams. And I'll show this one. Like, oops, change tabs. All right. Back to our update graph. So after we update ground state values, we update our cache. So we just set the previous actor location with actor location and the previous actor rotation with actor rotation. I like having my cache as a separate function that you update at the end of all your updates, just to make sure you always have your previous actor location, rotation, whatever value set in the right spot, rather than trying to set them right after you set your location or rotation main values. I just find it to be cleaner, and it's easier to not accidentally mess something up. And finally, we have debug, and it's a bit unorganized here. I have some stuff going backwards just because I wanted to change the order, but I'm essentially just checking started booleans, appending them onto strings, and printing those strings, and just to debug and see what's going on with the animation blueprint. So that's what's changed. A whole lot of cleanup, essentially. It's a much cleaner system now, and it should be harder to mess things up, run into issues, and it should be easier to solve those issues when we run into them, like the issues I was having with the pivots in the previous stream. Oh, and our distance matching functions have changed a little bit. You might have noticed in the event graph or the update graph, in both of them, there's no prediction calculations going on. That's because if I go to my ground locomotion, let's look at start first. We've bound distance matching start to on update. I'm just getting the distance to target, multiplying by -1, and distance matching to that target. And again, for it to work, you have to keep clicking the incorrect tabs. I use a sequence evaluator, and you have to set your explicit time to dynamic over here. Stops are similar. We're using our distance matching stop function. Oh, I'm sorry. I was incorrect. I'm not predicting it inside of there. I was misremembering something. If we go back to our update ground state values, if we go into update ground state values while stopping, we're predicting our ground movement stop location here before we determine our cardinal direction. For looping, we just determine our cardinal direction and our locomotion angle. And for starting, we just set our distance to target with the delta. So it's a very expandable system. But the next thing I want to do is I want to work on the start state and the stop state. Right now, again, we can only start going forward, so I want to add the functionality back in. So I have this Paragon video pulled up here, this conference video right here in another tab. And because there are sections of this video where they show their states, see, here is their start state. So they are blending between, for the first step of the start, they're blending between their distance matching two animations. They're blending between them. But then they also have a start animation, the orientation warp, and then they use that after the first step. Then they speed warp that, but that's something we'll add in a bit later. So we've never built this logic into our new UE5 distance matching system. So that's what I want to do today for the starts, and I want to do the inverse of this for the starts, for the stops. So you orientation warp until the last step. It's not what they did in Paragon, they just did a straight up blend, but I'd like to give that a try because I think it might look better. Just moving some tabs around. Okay, so okay, I'm trying to move my tabs around. All right, there we go. So we have our start anim A and our start anim B. We need a function for setting our start animations based on a cardinal direction and a secondary direction, and we need to be able to blend between them. And that's the first step before we do anything else. And to create a function for our start animations, we need a secondary direction, which we can derive from the cardinal direction. Let's say we're going between, we need to blend between a forward start and a right start. We use cardinal direction for forward and secondary direction, and that secondary direction would have to say a right. So let's just jump straight in. We need a new function. Determine secondary direction. And for our inputs, we're going to need our cardinal direction. And what else do we need? Our relative direction. Now, let's see here. I think I'm going to use another switch on int. Going to add 4 pins in for each of our cardinal directions. So if we are going forward, we need some booleans. We need 4 local booleans. So I will say local moving right. Now let's do local moving forward. I'll put a B before there just because it's how booleans are always named inside of code for Unreal, and I've just sort of adopted that for naming booleans inside of blueprints. The local moving right, local moving backward, and now finally local moving left. So okay, so does anim sync notifies work in blend spaces in Unreal Engine 5? I believe so. I don't think anything has changed there. I think so, yeah. I'm pretty sure they work in blend spaces, so yeah. Unreal Engine 5 actually has a new way of doing blend spaces. I haven't implemented that in this system yet. I plan to eventually, but if I just create a blend space here, you create your blend space in the anim graph. I can open it up, and I haven't actually used these, so I'm just going off of what I've heard or what I've seen from people who have. So it might take me a moment here. Add a new sample. Maybe, I'm not entirely certain here, but I know the really cool thing about this is that you can sample an animation, but you can also modify that animation. Like you could do orientation warping or stride warping on the animation before you sample it with a blend space. So I think you add a sample here. And yes, you then have a graph for that sample. So you can blend between from anything you can do on a graph. You can put your animation in, you can do stuff to that animation, and then blend. Oh, yep. Thanks, Ryan. So that's how the new blend spaces work. And I haven't played around with sync notifies and blend spaces in Unreal Engine 5, so I can't confirm that 100%, but I believe yes, the animation sync markers should work just fine. So you're welcome, glad I could help. Okay, so for the secondary direction, we want to take these booleans and we want to set them. And I was wrong. We don't need a left or backward, because a false on a forward means backward and a false on a right means left. So if our cardinal direction is forward or north, we will set moving, I'm doing all the wrong things. We'll set moving right. And again, Ryan has been working on his own distance matching locomotion system for a long time, and I don't need to reinvent the wheel, and he's given me permission to use some of this stuff here on the live stream. So the local moving right, we're going to set with, let's see, whether or not our relative direction is greater than 0. So I'm going to use our input, and the reason I have direction inputs on my functions, even if, let's say, you already have a direction variable and you can just use it inside the function, is because I just like exposing those things so it's easier to diagnose issues. it's personal preference, really. I like to have them exposed. The parameters that my functions use, more often than not, I like just to expose them so that it's easier to see what the function is taking and using to give its output from the graph where the function is called, instead of having to go into the function if things need to be debugged. I would not say that Echo's locomotion is a better approach than distance matching. It's a simpler approach than distance matching, and it's a really good approach. It does things really well, but in terms of fidelity, I think distance matching is still a little bit better. It's definitely a good alternative. I haven't spent enough time with it to have more of an opinion than that. I think distance matching does it a bit better, but, or at least there's a good distance matching system will have a bit more fidelity than Echo's locomotion. Really, an animation system is an animation system. I'm sure you could implement distance matching with Echo's locomotion. Distance matching is really just something you apply to starts and stops. Classically, like a Paragon locomotion system is distance matching and pose warping, where you have your orientation warping, your stride warping, your all that kind of stuff, and they're all just useful tools. You don't need to use all of them together, you can use all of them separately. So the Paragon approach is a great approach, but so is the Echo locomotion systems approach. It's simple, but it looks nice. But all the things here are just different tool sets that you can use to combine and like Unreal Engine 5 has support for motion matching and pose matching. The way I like to look at locomotion systems is I like to look at it in a layered approach. You have your underlying locomotion, which is just your movement. You're running around, you're starting, you're stopping. Then you could apply an IK layer on top of that. That could be, a procedural. That could be, when I say IK, I mean it could be a full body IK, interacting more with the environment. Or you could just keep it simple and do, what's the term for it? Like offsets for looking around. I prefer to do my offsets procedurally in control rig or with the bone transform nodes. That would be a layer on top of that base layer. I like to view locomotion systems in a modular manner, where they can be simple or complex as you need them to be in different areas. So you could just use a blend space in your loop, but then use distance matching in your starts and stops and not touch orientation warping, or vice versa. They're all tools that can be combined in different ways. Like pose matching is something I want to implement in this system, because right now the transition's using sync markers. The stops aren't really going to respect that, but I think we should be able to pose match from the forward state from the start state to the loop state. And I'm really curious. I want to try pose matching between the different orientations too. You're welcome for the answer. And so the reason it's been taking me so long to get a video out on this distance matching system, even though I started it, is because last time I did distance matching, I made a goal to get 2 videos out a week, a video out on Tuesday and a video out on Thursday. And at that point, I had never created a full locomotion, distance matching, and pose warping system. I was using an old plugin that wasn't that great. There's a better plugin for Unreal Engine 4, a free one on the marketplace. So if you're using Unreal Engine 4, don't use the one, and you're following with my old series, do not use the plugin I found. There's a better free one on the marketplace. Just search up distance matching, you'll find it. But I was figuring things out as I went. I'd created the separate components, but I'd never put them together, and I underestimated how much of a monumental task that would be. Right, thanks, Cole. Well, I'll definitely give that a shot with the orientation warping. So the yeah, so, and that's why that series, I'm proud of that first series. It was my the first series I did on the channel. I was new to YouTube, and I prioritized a consistency in my upload schedule and the frequency of my uploads over the completeness of the system. Now, that's important when you're trying to grow a channel, but it shouldn't be at the cost of the quality of your videos, and especially of your Locomotion system that you're trying to create and teach people with. And so there are things that never got implemented in that issues because I was rushing to try to get everything ready for a video. I was trying to create something in a day, enough for the next video, record that, and then edit it the day after that, and it was a mess. So this time, I went to get the complete system, or what's close to a complete system, figured out entirely, and then I'm going to use those components to teach things about Unreal Engine and animation with it once I have that complete system. And that's why I'm live streaming my process as I'm figuring this stuff out, so that you guys aren't waiting forever for videos if, you know, a week or two goes by where I'm figuring out the system. But once I have part of the system done, let's say this first underlying Locomotion layer without IK, maybe without any of the pose searching and pose matching stuff, I'm gonna make some videos on it. And while I'm making those videos, I can work on the next step, and the next step, and the next step, so on and so forth. And so that, let's say, this underlying system, maybe I'll eventually get around to a tutorial series on the motion matching stuff in Unreal Engine 5. This can be swapped out for that if you want. But everything I do with inverse kinematics on top of this should still work with the motion matching. That's the way I want to approach the new Locomotion series, which I think I'm going to call Next Gen Locomotion in Unreal Engine 5. Alright, so back to the logic here. So we want to set this local moving right, and we're just going to set it if our relative direction is greater than 0. Because we're going forward, and if it's greater than 0, then we are, our secondary direction is moving right. And if we are going right, then we are going to set our secondary direction forward. Remember, true is forward, false is backwards, and for right, true is right, false is left. And it's a really, really simple thing here. Now, if we are... okay. We also want to make sure for right, want to make sure that it is greater than 0, but also I think, and let me make sure I'm reading from some C++ here. So I want to make sure that the two and symbols is actually and I feel like it might also be or. It's yeah, because I think one and symbol is or. I'm not sure. Gosh. Okay, here, this tab might do it. All right, so that is and then that one's or. All right, thanks. So that is an and. So, gosh, I'm scattered right now. Okay, so relative direction is greater than 0, and let's see here. Relative direction is less than 90, that's right. And the reason for that is, so we have our cardinal direction, we know it's right, and so if our relative direction is greater than 0, then we could be anywhere from 25 degrees to let's say 135 degrees. And we need to know which side of right we're on to know whether we should be blending between a forward animation or a backward animation. So that's why we have this second one here. So if our relative direction is less than 90, but it's greater than 0, we know we're in between forward and right. But if it's not less than 90, we know we're between forward and left, and this should be false, and we should be blending with backwards. And now the logic is going to be this. Let's see. So now we're gonna set moving right off of our cardinal direction backwards. So it's going to be equal to, if the relative direction is, this should be greater than or equal to, not just greater than, because it's excluding the actual value that it's on. So if we're 0, it's not going to work unless we're using a greater than or equal to. And it's the same case for the less than. It should be less than or equal to. That was an oversight on my part. So if we are moving backwards, our relative direction should be greater than or equal, if it's greater than or equal to 90, and less than or equal to 180. And then finally, we are going to set our forward from our left cardinal direction. So if we are greater than or equal to -90, or actually -90. And we don't need our and here. So we've set this boolean, but now we need to turn that boolean into an output for a secondary direction. So let's add an output, and let's name that secondary direction. And let's make that an int. And complete system, I want to use an enumerator for each of these. It's easier to understand than an integer, but I was trying to be fast. At this point, it's probably a good idea to switch soon, or might be more work than it's worth. But for now, I'm using an int. So what we're going to do is we're going to create a sequence here between determine secondary direction and switch on int. And the second thing we're going to do is we're going to return a secondary direction. And now to figure out if we're going to return, we are going to actually, we'll just be duplicating logic if we do it that way. It'll be better to put the return after each of these. And we can just use a select int. So if we're moving right, we want to set our secondary direction to 2. If we're moving left, our secondary direction should be 3. I'm sorry, it should be 1. 2 is backward, 0 is forward. And we're just copying and pasting this select right here. And of course, we're changing the output. So, well, for moving right, it stays the same, but for forward, it is either going to be 0 for forward or 2 for backwards. Okay. So there is that function for our secondary direction. So I'm going to compile, save, and close out of that. Now we want to get our secondary direction in our start state and our stop state. Right now, at least, we do not need it in our loop state. So in update ground state values, I'm going to open update ground values or update values while starting. I'm going to open update values, whoops, not while looping, while stopping. So between cardinal direction and locomotion angle, I'm going to put in a determine secondary direction. Now we'll take our cardinal direction as input. And just to keep things clean, I'm gonna plug a cardinal direction in here so that you don't have that line going through that node. It's not that bad, but it adds up. So now relative direction, and you get our direction variable. So now we've set our secondary direction in our update values while stopping. Let's copy that. And actually we haven't set it. We've determined it. So let's set, let's set our secondary direction integer. Let's add. Okay, I just paused for a second because my video bitrate dropped. Let me know in chat if things are going slow or buffering with the stream. So. We do not have a secondary direction variable yet. I'll create one and I'll make sure it's in. Oops, where did I put it? Okay, in distance matching. So now I will set secondary direction. And now we will finally take this code and copy it over into our update values while starting. I'm bad at selecting and moving things right now, apparently. Okay. So now we have our secondary direction set where we need it to be set. Next, we are going to, well, now we need to determine the start anims and stop anims. I'm thanks, Ryan. I'm usually bad at organizing my variables. So I forced myself from the start, every single variable I made, to give it a category. And locomotion angle technically should go into distance matching. I haven't done that with all of them yet. I'm also trying to organize them by type inside of these. So, but I will break that rule sometimes if, you know, order of importance, or it makes more sense to go next to a certain one, like actor location, actor rotation. So lean angle, that can be a locomotion value, that's where I'm setting it. Delta time and character, I'm just not putting in there in a category. And so now, where were we? Yes, so time for another function. Now my function organization is crap. I organize my variables, but my functions are a mess. I'll need to go in and organize those. Yep, go ahead, take my categories, Ryan. I also, yeah, definitely. Just, yeah, it's so much easier when you stay organized, which isn't what I normally do, but I'm trying to be better about it. I'm sure as all of you know if you've seen the event graph from my old animation blueprint, or if you watched my previous. This is what I'm normally like. This is also what my previous distance matching series turned into with the graph, and I'm not going to make that mistake again this time. So, this new function, we're going to call it determine start anims. Our input is going to be our cardinal direction. And I always name my inputs differently than the variables that I'm plugging into them if I'm plugging in a variable that I know I have into them, so that you can actually, in a function, you can call the input and like get that into the graph without dragging out from it. It does the same thing, but it's much more organized. So I can get current cardinal direction. It acts like a local variable because there's no difference between a input and a local variable for a function. That's actually how it works in C++2. So there's a concept when you're dealing with memory and variables and allocating and initializing variables and giving them values. Every variable exists within a scope. So all the variables here exist within the scope of this distance matching of this animation instance. And when this animation instance is running, when it creates these variables, assigns them values, updates them, a local variable is created in the scope of a function. When that function runs, it creates the variable, assigns it a value, but as soon as that function's done, cleans it out from memory. But your input for your function, what you're essentially doing is in your parameters for your input, you're defining a new variable within the scope of that function. So the way you create the variable is different, but the effect is the exact same thing. You're just saying you can set all you're doing is you're allowing that variable to be set when you call the function. So also a cool thing, Unreal Engine that I just noticed recently working with, that's in the preview, It's not like a big new feature or anything, but it's nice. It's a nice little detail, a little tweak. I'll point it out in a moment here. So a current secondary direction is that if I have this here, this is grayed out because it's not connected to anything having to do with this. Or if this is selected, this is grayed out. Let's go to a function where it's easier to see. Let's look at calculate cardinal direction, or determine cardinal direction. So as soon as I select something, everything not connected to it is grayed out. It's a whole lot easier when your graphs get complicated to see your flow. A whole lot easier. I really like it. And I do not recall that being an Unreal Engine 4. Alright, so what we're going to do is we are going to have an output. Two outputs. They're going to be the type anim sequence. And I'm going to get a select node. Alright, let's just get it here without dragging out. There we go. So I'm going to have a select node for anim A and a select node for anim B. I'm going to select anim A with current cardinal direction and anim B with current secondary direction. I need to name these outputs. Start anim A. Start anim B. And so option 0 is going to be start, it's going to be for cardinal direction. Actually, I'm doing this wrong. I do not want to set these with integers. I want to set these with... Yeah, I do. My bad. Each of these is going to have 4. So if our current cardinal direction is forward, we get jog start forward. I'm going to copy that. So jog forward start. For 1, which is right. Jog right start. 2, which is backward. Jog backward start. And finally here we have 3, which is left. So jog left start. Now secondary direction is the same. 0 should be forward. So yeah, we can use the exact same thing here. Okay. Now I'm going to copy this because we need another function. Actually, I'm just going to copy and paste the function. And we're going to call it determine stop anims. And I want to follow naming conventions here, so I'm deleting the spaces out of here. I just want to use standard camel case. So for determine stop animations, I'm just replacing jog start with jog stop. So we're doing a jog forward stop. Whoops. We're doing a jog right stop, a jog backward stop, and finally a jog left stop. And again, should be the same thing here. not, and I mean it should be, but if it's not, I'll probably change the secondary direction function instead of changing this, but I'm pretty sure that's how it's working. All right, so we've now determined our start anims, so now we need to set our start anims. So I'll determine them after our locomotion angle. So determine start anims, and we're in update values while stopping, so we're going to do stop anims. So after that, we're just going to set stop anim A and stop anim B. Oh, I did not rename the outputs for our stop function. Okay, so now we need to plug in our inputs for cardinal direction and secondary direction. And now we're just going to do the same thing in our update values while starting. So now I have a question for you guys watching the stream. Earlier I talked about an animation series, but that's not the only series I want to start. I'll start it as soon as I'm ready for that. But as soon as Unreal Engine 5 comes out fully, I'm gonna start working on a series it's a full-on series. I want to teach Unreal Engine 5. You know, starting at beginner level, let's install Unreal Engine, to advanced stuff, maybe even a little bit of C++. By then I'll probably know enough to teach a little bit of it. So I'd probably end up covering animation stuff in there too, but I'm not sure how I should split it up. I want to do the animation series, but I also don't want to do the exact same thing in that series too, so I'm open to suggestions on that, guys, because that's a conundrum I haven't thought my way around yet. Okay, now we need a blend alpha. We need to blend between these two animations, because we know what our animations are, but what use is that if we don't know how we're blending between them? So previously I just might be a better approach for this, a more efficient approach for this. I think I'm just going to use the old approach that I used. I came up with it forever ago, and I've just been using it since, but I'm trying to think if there's a better way. What I'm thinking about doing right now is just using my direction, and based on my cardinal direction, I'm just using a clamped map range. I think I'll do that. Yeah, so let's determine anim blend alpha. Now our input should be cardinal direction. trying to think if there's a way to do this with secondary direction. Not sure. No, I'm not sure if that is gonna work. Let's see. Yeah, I'm gonna use cardinal direction, relative direction. So, okay, so let's, I think I'll use a switch on int. And for each of these, for forward, I'm going to get a map range clamped. So if we're going forward, I know that our value is going to be our relative direction. And in range A is going to be, for forward, it's going to be no, thanks, is that ESCOT or SCOT? I'm not sure, but thanks, I'm glad you find my tutorials helpful. And I'm planning on making more, and I think there's going to be a big jump in quality in the content that I'm making too. So I'm super excited to get back into the swing of weekly or maybe even bi-weekly videos on things. Just have to do the groundwork ahead of time to have things sorted out before I start just recording a ton of stuff. Awesome. They say everyone is their own worst critic, so I think I just have a case of that. So let's see. Relative direction, map range clamp. I'm just going to think out loud here. Yep, cool, definitely. If you've joined the Outcast Dev School Discord, there are a couple of channels, work in progress, and channel just to share what you're working on and show your work channel. So definitely post there, post what you're doing. I'd love to see. Okay, so relative direction. Gosh, I'm going back and forth between chat and this, so I'm going a little bit slow, but don't stop talking in the chat. It's why I do the live stream. I just might slow. I'm just going to try to regather my train of thought. So what we're doing here is we want to determine the blend alpha. So if we're going forward, do we also need to know the secondary direction? I think so. That would make this less complicated. I think so. So if we're going north or forward, we're going to get a mapped range value clamped between 0 and 90 and map that to 0 and 1. Our input being relative direction. Alright, yeah, I'm not sure about, I feel like I'm missing something here, because what do you need the secondary direction? I'm not sure, so let's just do it this way and see what's going on. That sucks that you're having trouble with the preview. It's interesting because I haven't had any trouble whatsoever, really. Are you using preview 1 or preview 2? I've heard that preview 2 is It fixes a lot of Preview 1 bugs, but I haven't even really run into any of those bugs yet in Preview 1, and from what I've heard, I can't confirm, but it seems like it's a little bit less stable. Just from what I've seen, that's like the gist of it, from what I've observed, but I'm not confident in that, but I feel like I've heard a bit more about people having problems with Preview 2 than with Preview 1, but that could be, I could be wrong. It could just be because most people have switched to Preview 2 and I haven't gotten around to it yet. So, okay, so in range A is 0, in range B is 90, outrange A is 0, outrange B is 1. And so let's get a return. Oops, gave us up a new input. So let's do a blend alpha as our output. And if we're going forward, oh, it should be the absolute value of the relative direction. And that will do it. That will make sure it works for left and right. Took me a second to think of that, but yeah, that's a way to simplify my old approach. Okay. Is that, I'm curious, I have Ryan's code here. Is that how he does it? Oh, yeah. Okay. So we're gonna do the same thing, just change the values, I'm pretty sure. Let's see, so if we are, let me think about this. So if we're going right, then we get the absolute value of the relative direction, and we're mapping that range from, okay. So we need to have two conditions here, because what works for forward is not going to work for right. Let's get ourselves a branch. It's the exact same case as the secondary direction and how we're determining that. Well, not the exact same case, but the underlying logic, the problem that we need to solve here is very similar. So let me think about it for a moment. So we just need to know if we're less than or greater than 90. So if we are, let's say, if we are less than 90, or if we are, we know that we're going right. So we know that we're greater than 0 and are less than 180. So now I need to know if we're greater than 90 or less than 90, but that excludes 90, so let's do, so if we're going 90 degrees, the blend alpha should just be 1 anyway, so yeah, let's do, doesn't matter either way, greater than or equal to, and if relative direction is greater than or equal to 90, we know we're less than or equal. We're going to blend 90 and 180. But if it is less than 90, so if that is false, we know we're going to blend between 0 and 90. Not blend, we're gonna map the range from 0 to 90. Or should it be 90 to 0? So 1 would be right because we're moving right, so 90 to 0. The outrange is, so we're at A, our alpha should be 1. So yeah, 0 to 90. That's right. We'll return that. And now for backwards, let's do left first. Let's just do left first. I was doing backwards because we have to think about negative 180 and positive 182. Oh yeah, I definitely want to do climbing system stuff too. That's something I've been wanting to do for a while, and yeah. I want to do more than ground locomotion with a tutorial series. I want to do climbing, I want to do swimming, I want to do maybe even flying. I just want to do different locomotion modes. Is why I'm trying to decide how I'm gonna split up, if I'm gonna even. I want to split up the locomotion series from the just teaching UE5 series. So maybe I'll try to build it in a way where the character is extremely basic. I'm just getting values from the character movement component and allow me to use the locomotion stuff in that series. I'm not sure. So for left, we're gonna check if our relative direction is less than or equal to negative 90. If it is less than or equal to negative 90, we know that we are blending between left and backwards. So negative 90 being left and negative 180 being backwards, and I think that might be flipped. Maybe I do need to flip it. Let me look back at. First, let's check forward. So 0. So we're blending from anim A to anim B, where 1 is anim B. So 0 would be forward and 1 would be right or left. That makes sense. So for here, 0 would be right and 1 would be back. So yeah, it's 0 and 1. And we're starting with, okay. So it's negative 90 to negative 180, but if we are greater than or negative 90, we want to blend between let's say 90. Yeah, no, negative 90. Yeah, from negative 90 to 0. Now, let's go back and do backwards. I had my input swapped around, so I needed to fix that. Or my outputs from the select swapped around. All right. So let's see here. Relative direction less than or equal to 90. So we need to. We could do this the same. I think this is going to be closer to start. But we need to know if it is. So we did start, just if it's greater than or equal to 90. No, that's not start. That is, we just mapped 0 to 90. So the absolute value of relative direction, which will give us 180 to 90. So should just be able to map the absolute value . So if relative direction is, it's either going to be like a 90 or 180. So let's do 90, 180, 0, 1. And I think that might work. So let's test it out. Let's go back to our update values while starting. Let's add a determine anim blend alpha. We're going to input our cardinal direction. We're going to input our direction. And then we're going to take our blend alpha and we're going to set a new variable. Let's promote it to a variable. Why isn't it letting me? What's up? Alright, I'll just make a new variable over here. It will be called anim blend alpha, I guess. And it will go in the distance matching category. So that'll be a real, and it's gonna set it from here. And so we should now be able to blend our starts. If I go into the start state, into start, and plug in anim blend alpha. I'm expecting this to not work. Yeah. That worked. Yeah, something isn't. So yeah, let's print out. Let's go into debug. And let's print out our start anim A and start anim B. So in this case, start anim A is jog right start, and okay, let me flip that around. That's going to be confusing. B. We should be printing this one first and this one second. Oh, come on, Unreal, you're... Ah, there we go. My debug graph is probably the messiest graph, but I don't really care too much about that right now. We're blending between jog forward stop and jog right start. Okay. Blending between jog forward and jog left. Okay. Jog left and jog backward. Okay. And jog right and jog backward. Okay. I guess that worked. I guess it's working, yeah. The jog forward and jog left is just a bit odd. Look at that in slow motion. Okay, yeah, that's not too bad. Foot locking would fix that, because we're blending, so... Okay, what was that? We should not be blending between jog left and jog right. There. So when we're going left, we're blending between jog left and jog right. That makes no sense. Our cardinal direction is west. We should be blending, we're blending between jog left start and jog right start. So that's the issue. So let's look at our determine start anims function. So where should we be blending between jog forward? Yeah, should be blending between jog left start and jog right start. So if our current secondary direction is so forward, right, backward, left, that's right. So it has to be when we're calculating our secondary direction, I think. Okay, determine secondary direction. We know this is an error that's occurring when we are moving left. So when we're moving left, we're checking if relative direction is greater than or equal to -90, and if it is, then we know we're moving forward. And so if that is true, we're outputting, aha. We want to blend between 0 and 2, not 1 and 2. There was the issue. So now let's try this again, slow-mo. I want to see what happens if we looks a bit off. Looks a bit strange. Maybe that's just me. Yeah, we're blending between the two animations, but then they're doing that spin around. It's jog left start and jog backward start. Stop anim A should be, okay, it is jog left start. Stop anim B is jog forward start, while our cardinal direction is west. Now if it's forward start to left start, I might be able to fix that by... Yeah, that's definitely what it is. Which I think is really, really silly. I mean, first you're going backwards for left, so it kind of has to be. But the blend then doesn't work well at all. So I'm gonna see, which is why I think, you know, that's why I like the ALS approach of, I know you like it too, Ryan, of, you know, starting backward and like transition, just where you can move, you know, backwards while you're going left, or backwards while you're going right, and forwards while you're going left, and forwards while you're going right. I like that approach, but that's a ton of work to implement with distance matching. I haven't tried getting that figured out yet. Not sure if I'm going to for this system right now, and sometime in the future probably. So let me think for a moment. Okay, I'm going back to the Paragon video, and I'm going back to my start state. We have our start state, and we want to blend between these for the first step, but then we want to transition over into orientation warping. And they have a couple of variables here: a start transition first step alpha, which is what they're using to know when they blend to the orientation warping. So like, I don't know, I'm trying to search for a variable that doesn't even exist when I'm trying to get my blend. So yeah, blend, okay. And so let's promote this to a variable. Actually, let's look at jog start. These curves should be built on into the Paragon animations. They don't. Oh man, that sucks. So that's the first step right there. So there's the first step, and from that point you'd want to transition into orientation warping, I guess. So you're gonna have to make a curve, which sucks. Included all their other curves, but not this one. I think maybe there's an easier way to do this. So that first step, and then you blend over to orientation warping. So let's see how that would be considered the first step. But I'm not going to consider. I consider that the first step, or I consider this the first step, or maybe this the first step. The animation's a bit. I guess it would be this one right here. So from this point, from here to here, I guess I'd want to blend between. Maybe I can use this disable speed warping curve. Starts at a 1 and goes to a 0, and it looks like it matches up here. It matches up on this animation, doesn't match up with the rest. So let's look at jog left start. Our disable speed warping curve, so I'm gonna try to use disable speed warping and see if that curve will work well enough for our purposes. So back into update. Let's go into the let's do it in the state. Let's get curve value. And we're going to need to multiply it by a -1. And what is the value called? It is disable speed warping. Okay, so now for this, this might be a bit more complex than how Paragon does it, but I'm going to try it this way first. Let's get our blend poses by int, our cardinal direction, and let's look at the loop state. What did I set the blend time to be on that? I'm not sure I'm happy with it, but I want to keep it consistent. 0.2, okay. So back into the start, let's set blend time to 0.2. 0.2. And we want to be able to blend between all of these, really. I'd be able to just use the 2 if we were to, yeah, so just gonna add 2 blend pens and gonna copy my loop state, just this. I don't have to put all the settings in the new orientation warping nodes. And now I'm gonna get let's see. Let's go back to the loop. Did I get rid of my evaluate nodes? Wait, no, start. Yeah, I was backwards there for a moment. So when I get these, just copy and paste so that they use distance matching. And I'm gonna get 4. I'm gonna change the sequence to first jog forward start, jog right start, jog backward start, and jog left start. Oh, whoops. Looking these in wrong. Compile error, what's going on here? Ah, wrong skeleton, wrong animation. 2 Paragon characters in here. I think that'll do it. Yep. All right. Now I'm just gonna take, let's look at jog left start. The distance coder goes all the way to 706, so I'm gonna change my threshold here. My start threshold to 300. Just so I can see what's going on. I don't think that is working. Let's look at this. Let's make sure the orientation warping is working. So let's not do that blend. Let's bypass the blend between the two and just look at it with orientation warping. You know what? I think I'm not going to do the blend for the starts. You have that little bit of rotation on the legs, but all you have to do is add a curve for foot locking in and a foot locking node and lock that foot for the first step, and it should look fine. And I think that'll get rid of the foot sliding. So I'm going to set that start threshold back down to 80. And our stops are not working for one direction. I don't think they'd work for... I didn't even know I was blending those. So we'll still want to use the blend for the stops. Yeah, we want to get our anim blend alpha and put that there for our stops. Now, again, there's foot sliding on the stops because of the animations. And that really sucks. I'd really rather. Okay. Let's go back into the start state and let's pull. Did I delete that logic? Yes. Okay, let's undo that. Ooh, something froze. And hooray, we crashed. Okay. Let's restart. Okay. Let's open our asset editors back up. So preview 1, not entirely stable, but mostly stable. Stable enough. But do we have our undo? No, okay. So that's fine. So let's go to our stop state. Let's get that and blend alpha. And then let's blend that with a get curve value. That curve will be disable speed warping. And is that curve there on the stops? No. So right here, this is where we'd want to blend it. We'd want to, let's look at it from the side. Let me explain my thinking here. So we're using orientation warping in here. From here, as soon as this foot is planted, we need to switch to a blend. So let's add curve, create curve, orientation blend. Let's open it up and let's add some keys. It's going to be 1 because we want orientation warping. And this one's going to be 1 because we want orientation warping here. Let's give ourselves a new curve. A new key. Going to be 0. And by the time this step is here, we want to be blended. Disable speed warping is not a curve in these stop animations. Or I would. Oops, not constant. We want to do auto. Okay. So orientation blend is what we're calling this. So let's do a jog forward stop. Curves, add curve, create curve, orientation blend. Open it up. And there's our final step. So from foot sliding, I'll show you what happens right now. Although I'm not sure if it's gonna. There's a ton of foot sliding. You can, I think Paragon's approach was just to make the stops last for a really short amount of time. I want to try to blend orientation warping into a blend and then use foot locking on top of that. So, alright, so I'm going to orientation warp until our last step. So I think that, I'll count that as the last step there, from here to there. So, what's down here? Let it add a key. From here to here, let's add a key. And at here, let's add a key. We're going to set the value to 1. And set the value to 1. And I guess we don't need a key at the beginning, do we? No, okay. I will check in a moment if it has a foot locking node. Let's see. Nope, I don't think so. So I'll have to do something similar to ALS, I guess. So that's jog forward stop, jog left stop. Forgot what I can call in the curve. Orientation blend, okay. So let's watch for the last, okay, so here, add key to here. Add key. This key is set to 1. And I'm doing an auto blend. Okay, so one more animation to go, guys. Jog right stop. Ooh, no, don't want to remove curve. Let's add an orientation blend. Let's save everything. Just in case it crashes. I don't think it will. It rarely crashes for me. So let's add a key here. And a key there. Set the value to 1. And now auto, so now that 1 while we're orientation warping, so we should just be able to plug that right into there. And what's the curve called? Orientation blend. And now let's copy it. Let's get our start state. Copy all of this into our stop state. And we have jog forward stop, jog right stop, jog backward stop, and jog left stop. And we want to use the distance matching stop function here. Save everything, and ooh, that that doesn't look super great for the final step. The final step blend really throws it off. That was interesting. So to fix that issue there, the jittering, and I will look into how I'm blending between these and getting the stops to work between now and the next stream. I mean, maybe foot locking, because that looked good. That looks all right. See, these look fine if we could reduce. These would look fine, I think, if we could reduce the foot sliding. So we take a step. Yeah, if we can lock the feet, I think it might work. And we just have to take like a advanced locomotion system like approach to the foot locking, I think. There's a bit of jumping around, but yeah, I think I'm gonna end the stream here. Went over all the changes. We worked a bit on starts and stops. So yeah, bit further to go here on the starts and stops, getting them to look nice. Not as far to go on the starts, further to go on the stops. So I'm gonna end the stream here. Thanks for watching, everyone. I will continue to stream my development of this system until I'm ready to make videos on the system, and I'm going to try to brainstorm up a video for this next week that I can get out, since this might take another week or two before I'm ready to start making videos on it. I don't want to, video number 2 go and change bunch of stuff from video number 1 or anything like that. So maybe I'll try to cover a bit of the IK rig stuff, even if it's just retargeting. I want to figure out the runtime retargeting. So thanks for watching the stream, guys, and I will see you all in the next video and at the next stream, and of course in the Discord. I'll share the link here in case you guys are new to the channel. I'd definitely love to talk with you all in the Discord. So there's invite link, and I'll see all you guys another time.